Good day. I am Invento, and in this day we're gonna be discussing various topics in Calculus 1. All differentiation problems we have encountered are functions like y equals to x squared plus 5x or y equals to sine x. The y is written explicitly as a function of x. This means that the equation is solved for y. In other words, y is by itself on one side of the equation. Note that y was sometimes written as f of x as f of x equals x cubed minus 4x squared. It's the same thing as y equals to x cubed minus 4x squared. Sometimes, however, you are asked to differentiate an equation that's not solved for y, like y cubed plus 3x squared equals sine x minus 4y cubed. For such a problem, you need implicit differentiation. Let's try this one. Y equals x squared y plus y squared x. First, we should differentiate each term on both sides. In this problem, we will be applying power rule and chain rule. Since we are finding the dy over dx, you can see in the second equation, there are power rule and chain rule. So bring down the 2, which is 2x, and minus 1, 2x minus 1, plus 2, similar to the first one, 2 minus 1, and so we will be applying the chain rule, which is x squared, dy over dx, then y squared. So for simplifying it, the answer will be 2xy plus x squared dy over dx plus 2yx dy over dx plus y squared. Second, collect all terms containing a y prime on the left side of the equation and all other terms on the right. In this stage, we will be collecting all terms containing dy over dx on the left side of the equation, which are x squared plus 2yx, and all other terms left on the right, which are 2xy and y squared. Since the x squared and 2yx are on the right side of the equal sign, this will change their sign as they pass through the equal sign from right to left, and all the signs of the remaining variables will stay the same. Third, the third step is to factor out y prime or dy over dx. To get the final answer, we should factor out the collected terms. Is x squared minus 2yx over 1 minus x squared minus 2yx equals, bring down the 2xy plus y squared and copy the 1 minus x squared minus 2yx. Cancel out the 1 minus x squared minus 2yx on the left, then you will get the final answer 2xy plus y squared over 1 minus x squared minus 2yx. In a real-world context, a derivative represents the rate of change of a quantity with respect to another variable. For example, the speed of a car. The speed of a car is the derivative of its position with respect to time. Moreover, in economics, the derivative can present the marginal cost or revenues change with the production or sale of one additional unit. Derivatives are widely used in various fields to analyze and understand changes in quantities over time or with respect to other variables. So our second topic will be higher order derivative. Have you ever been taught of getting the another derivative of your derivative, which you can call as your second derivative? How about the third derivative, fourth or fifth, and so on until you get 0? This is called higher order derivatives. To make this realized, let us solve this problem. f of x equals 1 over x plus 2. Let's solve for the higher order derivative of this problem while determining the general formula. F to the power of n of x. F of n of x. Before we start to solve the derivative, while observing the problem, we can identify that it is in fraction form. Then this leads us to solve the first derivative by the use of quotient rule. Before administering the quotient rule, we should first identify the u and v, as these are the function of x, which are 1 and x plus 2. Then we can now solve it already. The first function, the u, is 1, and the second function, v, is x plus 2. We will get its derivative as what can you see in the quotient rule formula. So the derivative of the first function, d over dx, is 0 since there are no other variables included. It is only a number. So it will become 0. For the second derivative, for the second function, x plus 2, then automatically the number 2 will become 0. So the x has an imaginary 1. So 1 minus 1 equals 0, and x to the power of 0 equals to 1. Then the derivative of the second function v is 1. Since we already know the derivative of the both functions, we can now substitute the variables and solve for the first derivative. Substitute the v for x plus 2, d over dx as 0, minus u as 1, and dv over dx as 1 over v squared, x plus 2 squared, equals negative 1 over x plus 2 squared. Move the negative sign to the middle part, left side of the fraction. Then it will become negative 1 over x plus 2 squared. So our first derivative is negative 1 over x plus 2 squared. In order for us to get the second derivative, we should somehow apply the negative exponent and expand the equation into x plus 2 squared to the power of negative 1. So in order for us to get the second derivative, we should apply the power rule since the first derivative has already been expanded for us to easily solve for the second derivative. Multiply the outer and inner exponents with regards to one of the laws of exponents, which is the power of power, for us to get negative 2. Then subtract to 1 to negative 2 for us to have negative 3. Apply the negative exponents to simplify the answer for the second derivative, since we already know. Apply the negative exponents to simplify the answer for the second derivative. In order for us to check if our general formula is correct, we can use 0 as our n. Then we can substitute 0 for any n and solve for it. So our proposed general formula is negative 1 to the power of n multiplied by n minus 1 factorial multiplied by x plus 2 power of negative n minus 1 multiplied by n. You can now conclude if your general formula is correct if the answer is 100% alike with the default equation, which is 1 over x plus 2. Our third topic is maxima and minima. This topic refers to the highest and lowest points, respectively, of a function or a curve. So let us try to solve this problem. Find the minimum amount of thin sheet that can be made into a closed cylinder having a volume of 108 cubic inches in square inches. Let's denote that r as the radius of the cylinder in inches, h as the h as the height of the cylinder in inches, and y as the volume of the closed cylinder. So y equals pi r squared h. We know that our y is 108, so we will substitute 108 to y. So 108 equals pi r squared h. We will be using the factorial in order for us to get the h. So 108 over pi r squared equals pi r squared h over pi r. Then our height of the cylinder is 108 over pi r squared. So in order for us to solve the area of the closed cylinder, let's use the formula 2 pi r h plus 2 pi r squared. Substituting the h, then it will become 2 pi r, close and open parenthesis, 108 over pi r squared plus 2 pi r squared. Simplifying it, it will become 216 over r plus 2 pi r squared. Simplifying the equation, it will become 216 to the power of negative 1 plus 2 pi r squared in order for us to get the r. So it will become negative 216 over r squared plus 4 pi r. To get the radius of the cylinder, we will now solve for the 4 pi r cubed equals to 216. Factoring the 4 pi r, so copy the 4 pi and copy the 4 pi, canceling it out. Ang mabili na lang is 216 over 4 pi. Since naa may cube sa atong r, ato siyang, let's eliminate the cube by using the square root. So we will use the 3 as our radicand of our square root. So dividing it and determining the square root of our equation, it will lead us to 2.58 inches. For us to get the height of our closed cylinder, we will use the equation that we already used earlier, which is 108 over pi r squared. Substituting the given r, the r which we already solved, then it will become 108 over pi multiplied by 2.58 inches squared. Multiplying 2.58 inches by itself, it will become 6.66 inches. Multiplying the pi and 6.66 inches, we will get 5.16 inches. To solve the area of the closed cylinder, we will now substitute all the answers we have gathered on each formula. So 2 pi multiplied by 2.58 inches times 5.16 inches plus 2 pi times 2.58 inches squared equals to 125.47 inches squared. Our last topic will be time rates. And let's solve this problem. Water is running into a hemispherical bowl having a radius of 10 cm at a constant rate of 3 cm cubed per minute. When the water is x centimeter deep, the water level is rising at a rate of 0.0149 cm per minute. What is the value of x? Let's denote that r as the radius of the hemispherical bowl given as 10 cm. x as the depth of the water, v as the volume of the water, and dv over dt as the rate of which the water is flowing into the bowl, given as 3 cm cubed per minute. Solving for the volume of water, we will use 2 over 3 pi r cubed. Finding the derivative of the volume, we will use dv over dt equals to pi r squared multiplied by the derivative dx over dt. Substituting the dv over dt, which is 3 cm cubed per minute, equals to pi r squared dx over dt. Since we already know that our dx over dt is 0.0149 cm per minute, we will substitute it already. So, since we already know that our r given is 10 cm and our dx over dt is 0.0149 cm per minute, we will substitute it already. So 3 cm cubed per minute equals to pi multiplied by 10 squared times 0.0149 cm per minute. The 10 squared will become 100. Then this will become 3 over pi 100 multiplied 0.0149 is equal to 314.16. Simplifying it, solving each problem separately, the 3 over 314.16 is 0.0095 cm cubed per minute, and the 1 over 0.149 is 67.11 cm per minute. Then the answer will be 0.64 cm, canceling out the similar variables, which is the minutes. So the answer will be 0.64 centimeter. Then this will become x squared minus 20x plus 64 equals 0. Factoring it out, it will become x minus 4 multiplied by x minus 16 equals 0. So our x can be 4 centimeter or 16 centimeter. Thank you.